In the previous unit, we discussed all different types of attacks in sort of very vague terms. But now we get into a little bit more specifics. We're going to talk specifically how wireless networks can be, or wireless devices can be attacked, not just networks, but also devices. And we're also going to talk about how to attack at the application layer, how to attack specific applications. So let me advance the slide here. So in the what is an attack? An attack is a vulnerability that enables an attacker to gain access. And that's mostly what we're going to talk about for wireless and applications. Let's talk about wireless attacks first. So we're going to talk about some vulnerabilities in wireless networking. Obviously, one of the things about wireless networking that sets it apart from other types of networking and also wireless devices is that you don't require physical presence to, or at least you don't have to have physical contact with a wireless device in order to access it, which is one of the things that makes wireless so much, so powerful. And everybody's been adopting wireless. It's, it's everywhere now. It's certainly nice that it is wireless, but that also presents some challenges with IT security. So the first thing that our book talks about is unauthorized access points, or rogue access points. Basically, a rogue access point is when you have you've got the border of your physical presence, your physical building or what have you, and somebody could sneak in, or an attacker could sneak in and install an access point. Just like a Linksys firewall that you and I might have at home. They could sneak in, plug that into the network inside the building, and then from outside the building, they'd be able to access your network. So this is obviously a major concern. It, in the old days, somebody would actually have to run a wire from inside the building, outside to their van outside to get into the network from outside the building. But with wireless access points, you can now do that from outside the network. The thing about the rogue access point is, you can go through all the work to secure what your wireless network inside the building. You can make sure you're using WPA2 and with AES encryption. You can have MAC address filtering and all this stuff to make it super secure. But if somebody sneaks in there with a rogue access point, then you have no control over that. So that's certainly a major concern, and you have to make sure that you don't have these rogue access points laying around the network. This is getting much more difficult to protect against because everything transmits a wireless signal now. So somebody can be inside your building with a cell phone and enable it as a Wi-Fi hotspot just so they could access the internet without using your network, which, maybe is a good thing, but that would show up as, a regular wireless network. So, how do we distinguish between those rogue access points that are connected to our network and the ones that are legitimate? Because one way that you could detect these rogue access points is to look for any device that's transmitting a signal inside your building, or SSIDs that you don't authorize, or anything like that. But so this is getting more difficult to crack down on, but it is something important to be aware of, this threat of a rogue access point. And likewise, when we talk about the triad of IT security, we talk about confidentiality, integrity, and availability. One of those things is availability. So availability in wireless networking means that it's available. We're able to connect to the wireless network, and there's nothing interfering with that. But wireless signals are very susceptible to jamming, right? So they can be jammed. There could be interference. All kinds of things can happen that would reduce our ability to access the network. And, like I said, that A in the CIA triad has to do with availability, and it's important that our network be available. That's a security concern. We don't want somebody being able to do a denial of service attack by jamming our wireless networks. So, like I said, wireless networks can be intercepted, they can be jammed, you can have interference. That interference could be by design, or rather not by design, but poor design, right? So if you have lots of wireless access points that are in close proximity to each other, they can interfere with each other. You could have different types of electronics that are between you and the access point that maybe the designers didn't think of. If you've got a microwave in the break room and you're on the other side of the break room and the access point is on the other side, then you might have difficulty connecting to the network. So all kinds of reasons that you might have difficulty connecting. So that's one concern. And then there could also be intentional jamming and interference. So somebody could intentionally jam that signal so that it's more difficult for people to access the network. One of the recent cases that's been going around the news lately in IT security is Marriott, who intentionally was jamming the signal in their conference centers in certain Marriott properties. They were doing this so that their customers who were attending conferences would have to buy the internet from Marriott. They wouldn't be able to do it on their own, right? So if they have that Wi-Fi hotspot on their phone I was talking about in the previous slide, if they turn that on, they wanted to block them from being able to use that. So that was a case of intentional interference or intentional jamming. The FCC did end up coming out and saying that the Marriott didn't have the authority to do that, and they told them that they needed to stop doing that. In the discussion, you could discuss that. You could talk about that. Was Marriott right for doing that, or was Marriott wrong for doing that? And you could go both ways in that argument. So Marriott's claim was that when people pay them $30 to access the internet, they wanted to make sure that they had good quality of service. And to do that, they were jamming on the other signals that might get in the way. That was their claim. It's sort of a dubious claim, but that was their claim, and you can make that argument. Certainly, it would help with the speed for the other folks there. The other side is that if I have a device that's able to access the internet, I should be allowed to use it. They can't block me from doing that. You can almost get into freedom of speech issues here with this type of issue. So you can have some interesting conversations about that. But we do have to be aware of jamming and interference. We have to be aware that our networks have to be designed properly so that everyone can access the wireless network that needs to, and those that aren't supposed to should not be able to jam our signal. All right, so another example from your textbook, another vulnerability is war driving. I apologize for the wrong header on this, but basically war driving is when the attacker drives around an area looking for open wireless networks. So they drive around, they wait until they see a broadcast ID, SID, and then they try to connect to that network. And if it's encrypted, they try to crack it if they can. If it's easy to crack, they make a note of it and perhaps move on. But this is basically just somebody aimlessly going around trying to find open networks. The term comes from the 1983 movie War Games starring Matthew Broderick. And in that game, Matthew Broderick's character is trying to access a computer somewhere that has some new game that he wants to play. He knows where the company is located, so he tells his computer to dial the modem of every telephone number in that area. So he knows the exchange, but he doesn't know the actual line number. So he just has the computer dial every possible line number trying to get a hit on a computer and then see if that's the right one. And if you watch the movie, he lands on one that's an airline, he lands on another one, and then finally he hits one that looks like it's a game. It's the screenshot you see here. And the computer says, "What game do you want to play?" And he thinks, "Oh, this must be it." And here's their new game, Global Thermonuclear War. So he decides to try to play that game, but the game is actually a war game on some kind of Department of Defense computer, and he very nearly starts World War III. And that's the basic plot of the movie. Good movie, worth seeing it. But that's where the term comes from. But instead of war dialing, we're talking about war driving. Kind of the same thing, but we're driving around looking for an open signal instead of dialing phone numbers over and over again. But this is definitely something that we have to worry about. In the old days, people would put chalk symbols on the curb in front of a building where there was open internet. I don't think it was typical to see that in residential areas, but you certainly saw it in in cities and things where there were lots of businesses. So if you were in the area, you would know what the SSID was that you could connect to, and they might even chalk up the password or the type of encryption or something along those lines. So how do you protect against war driving? Well, I guess the first question is, most people don't protect themselves from it, and that they prevent people from connecting to their internet. Instead, the approach that most people take is creating a guest network that's sort of a walled garden where people can't get into your network. 99.9% of the time, the people that are war driving, they're not looking to break into your network. They're looking to get access to the internet. So if that's what they want, it's what does it cost us to just give them access to our internet on a guest network, perhaps shape that bandwidth so that they're not infringing on the bandwidth that we need, but, kind of give them something. It's sort of like having a public bathroom, right? It's kind of the right thing to do, right? Maybe have a water fountain and a public bathroom in the lobby. Same kind of thing, just, have some public internet out there so people can use it. Otherwise, they're going to try to find a way to get into your real network, which is worse. So sometimes it's worth that little extra cost to accommodate that. And almost everywhere you go now, everybody has guest networks now. 5 years ago, it was uncommon to go anywhere and find guest networks all over the place. But now you go to the hospital, you go to the coffee shop, you go to McDonald's or Burger King. I mean, they all have Wi-Fi now. I've seen some Wi-Fi in some strange places. I think they had free Wi-Fi at the Home Depot. So free Wi-Fi is everywhere now. But, as far as residential Wi-Fi goes, they're kind of doing the same thing now with residential Wi-Fi, where when you buy the routers now you have a guest network. It broadcasts two SSIDs. One is guest and the other one is the internal one that you have to put the password in for. So we're even starting to see this in the home market, the residential market. So one thing you could do to try to prevent that is you could not broadcast your SSIDs so people couldn't see it. But most attackers have tools to get around that. So what we're really worried about with this whole word driving thing is somebody that we don't want connecting to our network that's going around trying to find open networks that they can connect to get into businesses and steal information. Those are the word drivers that we're really concerned with. And some people think, I can stop those guys by turning off the broadcast of the SSID so they won't even see it. But the reality is the signal is still there. And if you've got the right equipment, you're going to see that it's broadcasting on a certain channel, and you can brute force the SSID, all kinds of different tools to get around that. So don't think that turning off the SSID is going to protect you. You still have to do all the other stuff. Obviously, the best protection is going to be a combination of encryption, using WPA2 with AES, and perhaps even doing MAC address filtering, and then also having your own network security behind that. In IT Security 1, they should have talked about defense in depth, and that's certainly one of the things that we can think about to help protect our network. So that's basically word driving. We're going to switch gears here a little bit and talk about Bluetooth. So Bluetooth is obviously a wireless I think most of you are probably familiar with what Bluetooth is. We have two devices and they want to communicate. Usually this is close range, so you can pair two devices. So we use the term pairing to talk about connecting two devices. Most cases when you're pairing devices, you have to have a passphrase in order to connect the two together. So you have to put in some kind of passphrase to pair these two devices. Otherwise, somebody could just pair to anything, right? You wouldn't want somebody just being able to pair to your phone that you didn't authorize and then start doing things with your phone. So they have to put that passphrase in. One of the ways that Bluetooth works that makes it easy to use is this protocol advertisement, where it basically says, here I am, this is what I support, this is my name, and another device can see that to try to pair to that device. And most of us, I think, are familiar with that. If you get into a car that's a rental or something like that, you can pair very easily by clicking on the button on the radio. It displays the name of the Bluetooth name, and then you can connect to it and pair it and all that stuff, and they display the passphrase and all that good stuff. So it's not too hard to connect. So how can we attack Bluetooth? So there's a couple different ways your book talks about. The first one is bluejacking, which is where you're sending messages. So bluejacking is more of a nuisance than anything else. You're basically sending stuff to somebody's phone. And you're doing that by taking advantage of the contact transmission protocol, which allows you to send phone book contacts and even calendars and things like that from one device to another. So you could theoretically when you're pushing a contact from one to the other, instead of a contact, you can push text messages, audio and video, anything along those lines. In order for this attack to work, though, your device has to be in the discoverable mode. So usually when you're going to pair, and I'm sure most of you have seen this before, you put your device in a special mode to say, hey, I want to start pairing. You hit that button, and that at that time is discoverable. And during that time, that's when you would be susceptible to this bluejacking attack. I think the more modern Bluetooth, the newer protocol for Bluetooth, this is a lot harder to do, pushing these contacts to do something like this. And likewise, Bluesnarfing is also a little bit more difficult to do now with the newer versions of Bluetooth. They have some new stuff in there that makes this stuff a little bit harder. But as I said before in the previous unit, a lot of times we look at these attacks not so much to know what to protect against now, but to understand how people sort of poked our network and poke our devices to try to figure out ways to get around it. It helps us think about, if you can think like an attacker, you can start to think about how to protect yourself from these different attacks, because you're never going to be able to protect yourself by knowing every possible attack. You have to think about how people go about these attacks. That's why we study these different attacks, not necessarily because we're trying to protect against them specifically. But Bluesnarfing is another example, which again won't be common anymore, but rather than bluejacking, where you're pushing information to a device, with Bluesnarfing, you're pulling data out. And this uses the same protocol as bluejacking. It's taking advantage of this contact transmission protocol. And basically, the attacker can use that to get information from another device, like emails, contacts, the calendar, and so forth and so on. You can even get private videos and images that you didn't think you weren't intending to share. Pretty much anything on the device is going to be fair game for this type of attack. Your book talks about an application to do this called Bluver, which is an application you could use for Bluesnarfing. But like I said, this isn't very common anymore with Bluetooth 1.2 with anonymity mode. It's kind of difficult to do this attack. But theoretically, it would be possible, if everything is set up the wrong way or whatnot. But this is very easy to protect yourself from. Number one, don't leave it in discoverable mode, all the time. That would be kind of silly to do that anyway. I think most devices now won't even let you leave it in discoverable mode all the time. There's usually a countdown timer. One thing I want to mention about Bluesnarfing is kind of one way I've seen this work, and I've done this before. I rent cars a lot. So, if I go to a conference or something like that, I have to rent a car to get from the airport to the conference. And I find myself a few times a year in a car. And all the newer rental cars all have Bluetooth now on the radio, which is great because you can drive hands-free. If you're driving an hour, you can play your music through your phone and all that good stuff. So, it's nice to have that. But what a lot of people don't realize is when you pair your device with the car radio, you're actually sharing, typically, you're also sharing your contacts in your phone book and your calendar, and all that stuff gets pushed to the radio on the car. And a lot of these newer cars that have computers, instead of just being a dumb radio, it's a whole computer sitting there in the dashboard. They save all that stuff. So a lot of folks will pair the device in the rental car, and all their contacts will be in the radio. And I've gotten into rental cars where I'll see all of the contacts from the last person who rented the car, or somebody at some point who rented that car. When they paired it, they allowed all that stuff to get pushed to the radio, maybe just for convenience, and they forgot to delete it, or they didn't know how to delete it. And I think a lot of folks don't even know that's happening. They just pair the device and, drive away, and when they return the car, don't realize that the next person's going to have access to all that stuff. So I've seen that before. In fact, one time, I think I rented a car after an airline pilot, and it must have been an airline pilot, private pilot or something that had the car before me. And I saw all these phone numbers with airport codes. And I thought, well, gee, I wonder if that's some kind of secret number for the airport. So I started calling a few of the numbers, and they just beeped. And I was like, that's kind of strange. And I talked to a friend of mine that was a private pilot. And I said, do you know what those numbers could be? And he said, oh, yeah, those are the numbers for turning off and on the runway lights. So it's real small airports that aren't staffed in the middle of the night. You can turn off and on the runway lights by calling the number. So if you're flying in late at night, you can, use your phone and you can call the number and it'll turn the runway lights on, which is kind of cool. But, all that stuff was just sitting in that car radio for anybody to go and see it and start dialing those numbers. And I'm sure they're not intended for just anybody to call those numbers. So you have to be careful about stuff like that. So Bluesnarfing you can Bluesnarf yourself, basically, by sharing stuff with a public device like that. Although I'm sure that's not quite common. Another one that your book talks about, and again, this is another one that's not common anymore. Most modern devices, this won't work, but Bluebugging, basically the way this works is most Bluetooth devices, in order to, and I'm sure you've done this before, you use your Bluetooth device to place a phone call. And how does that happen? It uses AT commands. So with Bluetooth, you can pass these AT commands to what's essentially the phone dialer in your phone. Some of you may remember those old Hayes modems that you could use something like Hyperterminal to pass AT commands or to send AT commands to the modem to dial a number or, and so forth and so on, hang up and all that sort of thing. You can use those same commands, the same syntax to control the dialer on most cell phone devices. So if you can establish that Bluetooth connection and do that, you can use somebody else's device to make a phone call, basically, right? So you can, of course, you have to be in close proximity. It's not like you could do this and do it from a mile away, unless you had, a really powerful Bluetooth transmitter, I guess. But I'm sure somebody out there has figured out how to do this stuff. But in any event, you'll be able to use the device to make and receive phone calls without the person's knowledge. Now, like I said, this doesn't really work with the newer standards with Bluetooth. Most newer versions wouldn't allow this to happen without the device being paired and all that stuff. But this is something that was possible in previous times with Bluetooth. So back to switching gears again. Let's get back to more what we all think of when we think of wireless networking. Talk about packet sniffing. So packet sniffing in the wired world is when we jack into a network and we're listening to all the traffic, which, as you probably know, is a little bit more difficult to do than it used to be. In the old days, everybody used hubs. You could just jack into a hub somewhere, and you would be able to listen to all that traffic. You would be able to sniff all that traffic on the wire. Today, that's not as easy. You either have to plug into the correct port on the switch that's in promiscuous mode, or you have to trick the network into sending you those packets, and there's various ways to do that. But this is all still possible on wireless networks because, as I mentioned before, wireless is just radio signals. And I'm sure most of you have had somebody that you know or somebody in the neighborhood that likes to listen to a police scanner or the fire scanner, right? So they sit in their house and you turn the scanner on and you can listen to all the chatter between the police and the fire and 911 and all that stuff and know what's going on in the neighborhood. In the same vein, you could listen to all of the wireless networking traffic. So you could turn on you can basically packet sniff out of the air all this traffic. Now, presumably, most people today are using encryption. So this type of attack could be easily thwarted by using encryption with wireless networking. But that's not to say that if you have encryption that you are impervious to packet sniffing attack with wireless networking, because some encryption, as we're going to find out in a few minutes, are rather easy to attack. They're easy to get around, easy to crack. So you do have to make sure you use good, strong encryption to thwart this type of attack. But if you're sending your wireless data in clear text, you can pretty much assume that that data is available for anyone to listen. One of the most famous attacks with packet sniffing over wireless, I think, is Marshall's. And I'm sure a lot of you have heard about this, but there was a case where basically somebody parked a van out front of a Marshall's. Well, not just one; they went around to a whole bunch of them, and they found out that they were using wireless networking between the credit card machines and the server that processed the credit cards. And all the credit card numbers were being sent in clear text. They weren't being encrypted. So they just parked the van out front of the store and listened to all that traffic and just captured all the credit cards they could until they had, a good collection of credit cards that they could go and sell. And they eventually caught the guys that did that, but that was possible because they were using packet sniffing. There was no encryption. So at the very least, you want to make sure you have encryption on your network to protect against that type of attack. And this enabling that type of encryption on a wireless device should have been discussed a little bit in IT Security 1. We're going to switch gears again this time. This is a newer technology, near-field communication, NFC. It uses very short range, typically induction, like RFID tags use induction, same kind of thing, to send information between mobile devices. You've probably seen this where you've got, now they've got credit card machines at the Wawa. For those of you not in the area, that's just a convenience store and you're, in the Drexel area. But basically they have these credit card machines. You can tap your phone near the machine and it will charge you for your purchase. And that's one use of near-field communication. There are many uses. You can use it to share information between phones, maybe transmit your contact to somebody or something like that. But again, it's near field, so it's very, very short range. It has to be very close. I'd say that probably right now the largest threat to this is from losing your device. So if you use NFC to make payments and you've got it somehow tied to your bank account, and somebody gets a hold of your phone and your phone's not locked, then they're going to be able to start buying stuff with your phone as long as the phone doesn't get locked. And some people lock their phone, the baked-in locking on iPhone, well, not anymore, but it used to be on the iPhone and the Android. It was just a swipe to unlock the phone. So if you lost your phone, anybody could just swipe it. So to thwart this type of attack, make sure you lock your phone if you do use something like NFC. I think why is this concerning to us in IT security in the corporate world and in the organizational world? I think we're going to find that people are going to find ways to use NFC to steal information from phones other than being able to, steal contacts and things like that. And, a lot of folks now, especially in the corporate world, are storing a lot more stuff on their phones. Think about it. Your phones have all of your emails on there. So somebody could theoretically get copies of the emails if they could figure out how to do that with NFC. The data's there. The communication protocol is there. I haven't heard of any attacks like that. Maybe by the time you're listening to this lecture, you probably maybe have heard of something like that, and you can certainly put it in the discussion board and mention that, something everybody could look into. But NFC, like I said, it's not common yet. I don't think it's ubiquitous. It's not like Bluetooth where everybody uses it all the time. I think near-field communication is still kind of in its infancy. So as this starts to take hold, I think we're going to start to see more attacks using this technology. So certainly something to keep an eye on. Replay attack we already talked about. We talked about a replay attack being used previously to thwart authentication protocols. So what I discussed was that somebody could watch the authentication happening on a network. So For example, if somebody's authenticating to some device on the network, you could listen to that traffic and replay it and hopefully authenticate yourself in the same way. Now, most authentication protocols, most modern authentication protocols, this really wouldn't work anymore. They're designed in such a way that this is not possible with all kinds of different schemes to keep this type of thing from happening. But in the wireless world, we talk about this in the same vein where somebody could, I'll give you an example, somebody could listen to the traffic for the MAC address, for example, and be able to replay that traffic, and they would be connected as the same device, right? Although there's other ways to do that, just a very simple example. But somebody could certainly use the same technique, the replay technique, to try to crack or try to attack a wireless network. So it can be done on wireless networks with wireless protocols just as easily it could be done on our wired networking protocols. Most modern wireless networks would prevent this type of attack. But again, it's something that we want to be aware of, and we study these things. Like I said, we study these types of attacks to understand how people have attacked in the past so that we know, it helps us to understand the mindset and understand how people attack networks. I've mentioned a couple of times now, I've mentioned how important encryption is in wireless networking. We talked about packet sniffing. If you didn't have encryption, packet sniffing would be something just about anybody could do with the right software. So we have to protect that traffic because, they don't have to physically tap into a wire. It's just all flying through the air. Anybody can intercept that traffic and listen to that traffic. So one method to do that was WEP and WPA. These were older encryption standards for wireless networking devices. WEP at this point is, cracking WEP at this point is basically trivial. Anybody could do it. It's a matter of minutes, I think, now for some software to crack WEP. So WEP is at this point almost worthless. If you have a device that's using WEP, it might as well not be encrypting anything at all. The only people that are going to be thwarted by something like WEP is a normal user that doesn't know where to get some basic tools to go and crack that, which is, anybody who's actually trying to attack a network would, of course, know how to get these tools. So it's really not going to help us too much, WEP. What would help us, what we do use to encrypt our traffic, and most of you should know this already, is WPA2 with AES encryption. So you have to make sure you're using something like WPA2, which is the newer standard for encryption. If you're not using WPA2 with AES, then you're really opening yourself up to somebody being able to sniff that traffic and be able to get into your wireless network. One other protocol that your book discusses that has to do with wireless networking is the Wi-Fi Protected Setup, or WPS. And some of you may have seen this. Devices used to have a button on them for WPS. And it was basically a simplified method for setting up a wireless network. And you would press this little button on your wireless router, and any other device that supported WPS would be able to automatically connect and configure itself. So it would automatically set up the encryption password, and it would automatically get an IP address. All that stuff would get set up automatically, and then you wouldn't have to worry about it. This, I think, kind of came up because people started getting devices that were wireless, like printers, for example. So you'd be able to go out and buy a printer that connected through wireless networking, and you would hit the button on your router, you would turn the printer on, you would hit the button on the printer to connect it to the router, and it'd be connected, and you'd be done. You wouldn't have to go through any menus and push a bunch of different options and buttons and things like that. And a lot of those little interfaces on printers were kind of kludgy. They were hard to set up. So it made things a lot easier. However, if somebody were to press that button, if somebody knew you pressed that button, they would be able to also enable WPS on their device and connect to your network. And from that point forward, have unfettered access to your wireless network. Now, that's a little bit far-fetched, I think. For somebody to be able to attack that way, they'd have to know or somehow trick you into pushing that button. We talked about, or in this unit, we do talk about social networking. So, I'm sure there's a way somebody could social network their way into somebody pushing that button. So there's certainly, that's certainly one way they could attack WPS. The other way is you could either press that button, or the other way to get to do WPS was to enter a PIN. So every device would have a PIN that you could enter at any time into another device, and that would also automatically configure it to connect to your network. Unfortunately, those pins were very easy to brute force. So you could brute force that pin in a matter of minutes and get access. So once again, almost worthless, that pin to a real attacker. The only one you're going to keep out with that pin is a standard user that's going to say, "Oh, I don't know what the pin is," and move on. But anyone else who's an actual attacker, somebody who's actually going to try to get into your network, they would have little trouble getting around that. So how do we thwart this? We make sure we disable WPS on all devices. So any device you have that supports WPS, you want to either make sure it's disabled, or you can upgrade the firmware, and a lot of times the newer firmware will prevent the option from ever even being turned on again. So I have a router where I did that. I updated the firmware in my Action Tech router, and after that, WPS was completely disabled. I didn't even know that was going to do that. I just did, I said, oh, there's a newer firmware available. I'll go ahead and update it. And after that, the WPS light never came on again. And when you go into the options in the router, it was completely gone. So that's one way you could do it. And again, the other way is just disable it if the option is there. If you can't disable WPS, then it's probably best just to replace the device. And I think most networking devices in the corporate world, most wireless access points are not going to have this option anyway. This is mostly on home-based devices. But as you probably know, home-based devices typically find their way into a lot of network scenarios in the corporate and organizational world, so we still have to worry about that stuff. So we talked about a whole bunch of different ways to break into a wireless network, to attack a wireless network. Not just wireless networks, but we also talked about devices when we talked about Bluetooth and NFC. And of course, packet sniffing could be used on all this stuff. So, lots of different options. So things to think about as far as ways to attack a network. And most of these are from your textbook, by the way. Your textbook has a paragraph or two about each one of these different methods. So now we're going to switch gears entirely again, and we're going to go in and talk about application attacks. So these are attacks that you can do against, or that our applications are vulnerable to. So we're going to talk about a bunch of different ones. Now, one thing I'll preface this by is almost all of these attacks I'm going to talk about are really geared towards the web, right? So these are mostly web-based applications you're accessing over a web page. So if you think about how a web-based application works, most web-based applications have a form on the internet that people go out and they fill out this form. And when you fill out a form, you click a button and it sends that information to the server. The server processes that information and then does something. That's the key vulnerability to all of this stuff. The key is that somebody out in the public, out in the internet, is accessing your server through that form. And it's through that form that people can typically attack you with these web-based applications. And there's lots of little tricks to doing that. It's kind of amazing when you think about all the ways that people think about how to break into networks and think about a very basic form on a web page asking for an email address. If you don't protect that form and validate the input on that form from people in the public, you're opening yourself up to all kinds of different attacks. When I think of IT security and attacks, sometimes I think of a knit sweater. And you've got, when you think about a knit sweater, if you have a tiny little hole in a knit sweater, you can stick your finger in that hole, and you can kind of twist your finger around until all of a sudden you can get 2 fingers in that hole, and 3, and then you can get your whole fist through that hole, and all of a sudden you get your whole arm going through a little tiny hole in your sweater. And IT security is kind of the same thing, right? It's our knit sweater, and if you have the tiniest pinhole, and somebody can get their finger just slightly into that hole, they're going to twist it around until they can get their whole arm through it, and they can practically walk through the hole. So we have to be concerned with even the simplest things that people can take advantage of. So I'm going to talk about a couple different examples of application attacks. The first one that your book talks about is cross-site scripting. And this is where an attacker can submit some code to the server, which the server then executes that code. There's really 2 types that we talk about. The first one is reflected, where somebody submits something in a form, some kind of code, and that code is parsed and reflected back to the user. So that's one method. The thing about reflected is you have to actively submit that data. Now, there's 2 ways to submit information on the web. You could submit it in a form and hit the submit button, or you can provide information in the URL that gets submitted to the server. So we'll talk about that. I'll show you an example of that. But that's usually where you'll see these reflection attacks, where a URL is sent with some random stuff in the URL that when you click on that URL, even though it's a trusted site you're going to, and a user recognizes that site, it still carries out some malicious intent through that extra code that's typed into the URL. What something might be encoded in that URL that the server parses and then reflects back to that particular user. So that's one method. Now, what most attackers really want to do is get a persistent cross-site scripting, where they do the cross-site scripting attack one time, and then that's reflected back to everyone that goes to the site thereafter. So that's a persistent cross-site scripting attack. And I'm going to show you two examples of this. I'll show you an example of both. Let's start with, I'll pull a window over here. So here's a simple search engine. This is Google's sort of playground search engine that you can use to test some of these cross-site scripting attacks. I'll put the link in the course so you can see this. But just to see how this works, let's say I do a search for test, right? So I searched for test. It didn't find anything. But what I do see here is that it reflected what I typed in, right? So I typed in test, and I get test back. It shows it to me in the here in my results. It says nothing came back. So I'm going to hit try again. But this time, instead of just typing test, I'm going to put a little HTML in here and see if this reflects the HTML. See if this HTML is displayed back in that browser. So I hit search. Now take a look at that. I've got an underline in here now. So the U and the ending U tag basically cause it to display this with an underline. I can prove that if I look at the page source. So take a look at what is sent back to the user after that's submitted. Right in the body of the document, I now see test that's underlined. So this is another, this is a major security flaw because somebody could put any HTML they want into this search box. And it's just going to reflect back to the user. Let's take this one step further. I can use the script tag and embed JavaScript inside the script tag, right? So if a browser encounters this little JavaScript, it's going to do whatever you tell it to do. In this case, I hit search. Notice what it did. It gives me a little JavaScript pop-up that says hi. Pretty benign, but take a look at the source. There's my JavaScript right there, right? So it's embedded right in here, and it just reflects that. So that's obviously a problem. Let's do something a little worse here. So let's try to do a little reflection attack here. Let's say, and I'll copy something else in here. So let's say we write a little JavaScript that does nothing more than launches a pop-up window, right? So it launches a new window with a website. It just takes you to another website. So this time I'm going to hit search and watch what happens. I hit search and I end up on this web page, right? So I have a URL here that looks legitimate, right? And it's got a query string that has all this junk in it. Most users don't look at all this junk up here in the query string, right? In the get parameters in the URL. They're just going to click on the link. And in this case, it's going to redirect them to some other website. Now, what I could do is instead of making this a legitimate website, I can make it, www.badguy.com. I have no idea where that goes, but notice now it's going to try to open up badguy.com. So what I could do if I'm an attacker is I could email people this link with this cross-site scripting attack embedded right in the URL. Most people are not going to even look at this. They're just going to click the link, and then it's going to reflect the whatever code is in there is going to get reflected through the browser, and they're going to get the an attack. It could be redirecting to some website with malicious code. It could be anything. So that's one example. Let's take a look at another example. Let's see if we can do the persistent attack. So here's another test website. Again, you can try this on your own if you want to. This is going to be susceptible to the exact same type of attack. So take a look here. If I type test and I share that status. So let's say this is a simple social networking site, or it could be a blog. And this is the comment section of the blog. So let's say you have your own little blog. You wrote your own blog, and people can post comments on your blog. And you're just going to, output whatever somebody puts in here. It's just going to put it out. It's just going to, throw it out there for other people to read at the end of the blog. Simple enough, right? An innocent enough feature to put on a blog. So I type test and it reflects test. I could now let's say that people could inject some code, right? So you can see here that this worked. I was able to do underline. And let's also try doing a little JavaScript here. So if I post a little JavaScript, now that didn't work, right? So maybe whoever wrote this site was smart enough to make sure that the JavaScript wouldn't get reflected to protect themselves from cross-site. So they allow you to output HTML, which is good because maybe somebody wants to do some HTML formatting in their comment, but JavaScript is going to get suppressed, which is good. We want to suppress JavaScript. But sometimes there's a way to get around that. So let me show you an example. So now I'm going to post, I'm going to try to do an image. So this is just HTML, right? So this is just straight up HTML. It's supposed to work. However, I didn't put an ending tag on this, right? So we don't have an ending tag. So it's going to error, and we have on error to do a little bit of JavaScript. So this is going to kind of trick this system into doing something. So I'm going to hit the button to post it, and it posted basically what this did. I'll hit the F5, and it does it again. Basically what that code does is it creates a cookie and sends the session ID for that cookie. So maybe that could be sent to somebody else who's then going to hijack the session or something like that. So that's the type of attack you could do. Now, the interesting thing about this is I'm going to go ahead and hit enter, and notice that every time I go back to this page, every time I refresh this page, I'm getting attacked again, right? So this is persistent because the code is embedded in these comments that are persistently displayed. I now have a persistent cross-site scripting attack that every time somebody goes and looks at this blog, as long as this comment is here, it's going to attack. It's going to do this. Okay. Now, one more example. If you take a look at some, we've got some other code here that I can show you. So here's some JavaScript. Now, this is a pretty long JavaScript. It's from this site. So if you go and read this tutorial on how to do a cross-site scripting attack, you'll actually see, you'll have access to this JavaScript. Basically, this JavaScript does some, some crazy stuff. But how do I call this huge JavaScript file from, just by posting a little comment? So what I do, I'm going to do the same thing I did before. Use that image tag. So here's my image tag that's open but never closed, and on error, we're going to tell it to call that JavaScript. And you can see it's located right here, so I'm going to give it the path to that JavaScript file. So I'm going to hit share status and watch what it does. So first I get the pop-up, and then I get this. So here's an example of defacing a web page, right? Or worse. So now it's going to go and do some stuff, and every time somebody goes to this page from now on, it's going to do this until whoever owns the blog goes and fixes it and gets rid of that post, basically, that has that malicious code in it. So again, you can kind of get a sense here of all the things that somebody could do to attack a website with these cross-site scripting attacks. So how do we prevent these cross-site scripting attacks? The most important thing to do is to sanitize input. So we want to sanitize our input so that we're stripping out anything that could be used to attack our website. One of the reasons this is so important today is a lot of the things that we do with corporate environments now and organizational environments is we're using a lot of web-based applications now that, stuff that's on the web. So, gone are the days where everything's client-server applications that are proprietary, that are all inside the network. Nowadays people use these web-based systems to do things. So everything's out there on the internet. So we have to protect ourselves from these types of attacks. Somebody could even attack our system just from the login prompt in theory. And we're actually going to kind of talk about that a little bit with injection attacks. There are, our book talks about 4 types of injection attacks. They talk about SQL injection, LDAP injection, XML, and directory traversal. And these are all different types of injection attacks. I would argue that cross-site scripting is also kind of an injection attack because you're injecting code into a website, more or less. But these are the more traditional injection attacks that people usually are talking about, one of these 4. Really, for the most part, SQL injection. That's the one that most people are familiar with, SQL injection. LDAP, not so much. It's a newer protocol. Or it's not newer. LDAP's been around for a long time, but it's just now starting to pick up steam in the web application world. XML's been around for a long time, and we can attack that as well. And then we got directory traversal rather. So I'll talk about these 4. So let's start with SQL. That's the most common, I think. And I got this from on the web. I put the URL in the presentation. You can go and read through this tutorial where they walk you through how to do a SQL injection attack. It's kind of fun to see how this stuff works, but most of you hopefully have taken a SQL class, 1 or 2, and are familiar with SQL syntax. And you can see here a very basic SQL statement. We're selecting some columns from a table where the email address is some variable. And that variable is going to come from our input. So this is the code that might be on the server side. So a user is going to type in an email address, and that variable is obviously going to be substituted for the email address that they typed in. Now notice that there's a beginning and a closing quotation mark around that email address, and that's something that we're doing in our code. Hopefully the user's not including those beginning and ending quotation marks. But if somebody did happen to put a quotation mark on the end of their email address, for example, one of two things is going to happen here. So let's say this is our attacker that puts in this email address. Either the attacker is going to see that it fails, indicating that whoever designed the web application is not sanitizing those quotation marks. And if they're not sanitizing the quotation marks, chances are they're not sanitizing much else. So now the attacker is going to say, okay, I've got a system that's probably vulnerable to a SQL injection. Or it's going to work because they properly sanitized the email. So their email address is going to get added to whatever they typed it into. So let's say this attacker really wants to ruin somebody's day. So they're going to, in that web form where they provide their email address, instead of just putting in an email address, they're going to put Y, close quotation mark, semicolon, right? That's going to end that first statement. So that select statement, the first statement ends on that semicolon after that quotation mark. And then a space, and then they're going to type in whatever SQL they want to run, followed by, and then the ending quotation mark will be on the end. So you just have to make sure you end with something that would be valid with that quotation mark. So in this case, if you take a look at that, that's going to update some table and set all the email addresses to hacker@ymail.com. So whoever owns the website is going to suddenly find that all of the email addresses are the same after the person runs this attack, which of course is, not what we want. So that's a simple example of a SQL injection attack. The important thing is somebody crafted an input string for a web form that they knew was going to carry out some other command. Just by knowing a little bit about how SQL works, they're able to carry out a SQL injection. One of the things that people worry about too is accidental SQL injection, where somebody accidentally puts information in that might cause a SQL injection or cause something to happen. There was a comic strip from XKCD. I'll put it on the screen here. It's kind of funny. You can read it, but it's school calls the mom. The mom says, they said, "Oh, did he break did little Bobby break something?" And they say, "Well, did you really name your son Robert?" Single quote, open parenthesis, semicolon, drop table students. What's drop table students going to do? It's going to drop the table students, right? And delete everything in that table. Yeah, little Bobby drop tables, right? Oh yeah, we call them Bobby drop tables. But yeah, hope you're happy. We deleted all the student records. So, could somebody really do this type of attack? Well, in theory, if it's a really poorly designed grading system, and I'm sure there's no shortage of those out there, but that's just kind of a funny little example of that. XKCD is a great little comic strip that you can go online and find and read some other funny comic strips. So the other one we talk about, the other type of injection is LDAP injection. So LDAP injection is when we take advantage of LDAP. So let me explain how LDAP is used. Your book doesn't really explain this too much, but basically a lot of web applications, so the big buzzword right now, and has been for a while, is this idea of single sign-on. The idea is that you have one user account, and that one user account works on all the applications within an environment. So it doesn't matter what you're logging into, it's always the same username and password. And where possible, if you're already logged into the network, those credentials are passed to other applications. So it carries through all the different applications. In the Windows world, this happens through Active Directory. And a lot of you are probably familiar with Active Directory and how that works. So you log into the domain and your credentials are passed to all the other applications. But if you've got a Unix or a Linux application or something that's not deeply embedded in that Windows environment, it's kind of hard to use Active Directory. So LDAP is kind of a workaround to that. Active Directory supports LDAP for querying things in Active Directory. So the way you do this is a user gives you a username and a password. You take that username and password and you use it to connect to LDAP on a Windows Active Directory network. You connect to LDAP, which you can do from Unix and Linux with that username and password. And then you query LDAP for that user's username and all the additional parameters that Active Directory would normally give you. So normally Active Directory would give you the user's preferences, the user's last name, the first name, their location. All that ancillary information would come from AD, but you can also get that from LDAP. So the way that basically what that query would look like is if I'm querying for a username, I would do cn equals and then the username I'm looking for. You can see in this case, in that little code snippet on the top, I might be looking for a user ID from a form input. So maybe my user ID is BCG28. That's my Drexel ID. So if I were to query Drexel's LDAP server for that user ID, you should get all the information about me. But what if a user understood how LDAP works and they pass an asterisk instead of an actual username. So when they're in that login form, instead of putting BCG28, they put star. And when that star goes to LDAP, what that basically means, it's wildcard. It's find me any user ID with this, any user with any user ID. Just show me everything, basically. So that's one way you can sidestep LDAP. I don't have a lot of examples of LDAP injection because it's not, a commonly understood and studied thing right now, but I think this is going to start becoming a much bigger deal. So LDAP, just like SQL, has its own query language. That's a little different, of course, than SQL, as you can see here, but we can take advantage of this just like we can with SQL. We can inject some code in here that sort of would trick the parser into querying LDAP for the wrong thing. I think right now, as LDAP patterns start to emerge, one thing about SQL that makes SQL injection attacks a lot easier is we have these sort of standard patterns in software development. The way that people use SQL is very similar across many different web applications. We all kind of do things in a sort of de facto standard way. LDAP really hasn't gotten to that point too much yet, but I think we're getting there. And as more and more applications and web-based applications are starting to support LDAP for their authentication and for other things, we're going to start to see more and more attacks using LDAP. So that's basically an LDAP injection attack. Another example is XML injection. So I think most of you are familiar with what XML is. So here's an example of an XML file. So let's say we have an XML file called passwords.xml, and that file is what's used to authenticate users to our web-based application. So instead of using LDAP and instead of using SQL for authentication or Active Directory, we're just using a flat file. And maybe we've got that flat file protected somewhere, it's in a different directory that people don't have access to and what have you. But when somebody goes to log in, we're comparing the username and password to what's in the XML file. And the standard way of doing that is something called XPath. So XPath is a query language for XML. So we talked about the SQL query language, we talked about LDAP and its query syntax, and now we're learning a third one, which is XPath. And XPath allows you to query an XML document. So in this example, this might be a little code snippet where we're going to pass a username and a password to XPath. So XPath is going to look for a username that is equal to user, or to whatever's in the $user variable, and a password that's equal to whatever's in the $password variable. And there's an and between the two, so they both have to be true. So if both of those are true in one XML element, it's going to return that whole XML element, which is going to tell us, okay, we can log this person in. So in this case, if a user passed the username admin and the password my password, it's going to find user ID 1, and our user gets into the web-based application. Everybody's happy. But if somebody comes along that knows how XPath works and knows how to take advantage of that, just like SQL, they can inject their own code. So here, the user puts admin, single quote, or 1 equals 1. Because there's an or in there, think back to your 5th grade math with, please excuse my dear Aunt Sally, right? The order of operations. That or is going to ruin their day. It's going to basically return all of the elements in XML. So if we have a poorly designed application in this case, it's going to return all of the user IDs. And if our poorly designed application just takes the first one that comes back, then it's just going to use the admin account. So we just got in as an admin without knowing the password. So that's an example of an XML injection. The last one we talk about is a directory traversal or transversal attack. Basically the way, and it's not transversal, sorry, it's traversal, directory traversal. The way a directory traversal attack works, normally when you go to a website, so I go to somewhere.com, I'm going to end up on some kind of index page. That index page, on that index page, I might find some images. If I right-click on an image, it's going to tell me the path to that image is going to be in some folder called images. And then inside that folder are a whole bunch of JPEG images, for example. So if I go in the URL and I type somewhere.com/images, I could potentially get a list of all the images that are on that website, and I can go and click on all the different images. Not very interesting, and not really something I could use to attack the site. But think about when you're at the command prompt in either Linux or Windows. If you want to move back, if you want to move down a directory, you have to know the name of the directory, right? So I have to type cd space images to get into that images directory. But to go up a directory, all I have to do is type ... right? cd space ... takes me up one directory. So if I did that in a URL, then potentially I could end up in a root directory, some root directory outside of the directory I'm supposed to be in. even though it's not in public. Public underscore HTML is obviously where all of the public HTML files should be, and that should be the sort of playground, the little sandbox that that web pages are allowed to be in. Nobody should ever be able to get out of that. But if we had a poorly designed web server, and almost no web servers would allow you to do this, but if somebody wrote their own little web server, maybe it could be a shell script running a web server or something, then in theory this could be possible. Somebody could put the ... in there, get up a directory, and see that there's two directories in here, a top secret and public HTML. So then they could put top secret in there and see that there's a file in there called passwords.txt, and then they'd be able to put that whole thing in the URL and basically get that passwords.txt file. And then they've got everybody's passwords, game over. So this is an example of a directory traversal attack. Not very common, I think, for web applications so much anymore, especially because most modern web applications are pretty good about blocking this type of attack. But it certainly could happen with FTP. It could happen with SSH and things like that. So, SCP as an example, you could do something like this if you don't properly set up the server to prevent this type of attack. All right, so we talked about 4 types of injection attacks. We talked about SQL, LDAP, XML, and finally directory traversal. So now let's go back to some more traditional attacks. And I'm sure some of you have seen this old chestnut, the buffer overflow. Very common. Just about every IT security course since 1994 has probably talked about buffer overflow attacks. I'll give you a quick rundown of what a buffer overflow attack is. So let's say you've got some memory, right? So you've got memory that can be used by lots of different applications, right? We got a multi-user system. Lots of different applications can use the same memory, but each application gets their own little address in memory. So let's say program A gets 16 bits of memory assigned to it for a variable. So program A creates, needs basically when it compiles, or when it's in runtime, it needs a variable. So it gets a little space in memory for that variable, and it's 16 bits. Program 2 might have 24 bits of memory that it's using. And who cares what's in there? Just some random data in program 2. The important thing here is that program A is the program that we're interacting with as the attacker. And program 2, we know one of two things. Either A, we want to crash program 2, or B, we know that program 2 is running with more elevated privileges than program A because we're interacting with program A in a user space, and maybe program 2 is running in the system space with root privileges on, say, a Unix machine, or in Windows with the administrator account or something like that. And we want to take advantage of that program. So the key here is we want to get data into program 2's memory, but we're only allowed to use program A's memory, which gives us 16 bits. So let's say just randomly we have the integer 39,321. That's a 16-bit integer, right? So it uses 16 bits. So I can easily store that into that 16-bit variable, into that 16-bit address space in memory. By the way, if you want to learn more about how programs use memory, if you learn how to write C or learn the C programming language, it's a great exercise in learning how memory works. So if you want to really understand buffer overflow, you can learn C, and it would give you some really good insight on how this works. But in any event, I just wrote some stuff into program A's 16 bits of memory, but program 2 has 24 bits of memory adjacent to that. So let's say I know that the number that I need to get into program 2's memory is 13,107. Now that could just be random stuff that I'm going to write into program 2 just so that the application crashes or locks up or whatever. Maybe that's my goal. Or maybe I can craft some very small program that if I write this into memory, it's going to get executed by that program somehow. Either it goes to the processor and gets its basic instructions that are carried out by the processor. Who knows? But I know I've got something that if I can get it into program 2's memory, it's going to get executed in program 2's space, or in their root user space or the system space, and it's going to do some harm that I couldn't do otherwise with program A. So that's the data that I want to get into program 2. But how do I do that? How do I get that into program 2? Well, basically, if I have a variable that's long enough, so let's say I've got the integer, 2,576,954,163. That's a pretty large integer, which would easily be well more than 16. That's our 16 bits plus the 16 bits that we want to shove into program 2. Well, if I write that into program A's memory address, it's going to overflow into program 2's memory. So you can kind of see that that overflows into program 2, and that's our buffer overflow. So our buffer overflow happens when we intentionally craft a variable that's way too long, and it pushes into a portion of it pushes into some other program's memory. Originally, this was mostly bugs, right? So in the old days, this was a bug. Somebody wrote a program and didn't size the variable properly or use memory properly, and data would just overflow into some other memory space, and you could have things like memory leaks. You could get system lockups and things like that. But some astute attacker somewhere along the line figured out that they could do this and use this to their advantage, and that's basically what a buffer overflow is. So any program could be susceptible to a buffer overflow, and really any poorly designed program could do this, right? So you could have a novice programmer that writes a program that's either susceptible to or causes these buffer overflow types of attacks, or somebody could maliciously do this on purpose, right? So that's the other possibility. 0 day is the term used to describe a newly discovered vulnerability that hasn't been addressed yet by a fix or a patch. So it's basically a known vulnerability that for which there is no fix for yet. We don't have a way to patch this yet. So once a vulnerability is discovered, until the time that there is a patch available or a fix available for the application for which that vulnerability exists, we refer to that as a 0 day attack or a 0 day vulnerability. Normally, if you have an application that is susceptible to some new vulnerability, so let's say you or I discover a vulnerability in some commercially available application, the right thing to do would be for you or I to notify the company that makes that software, give them a reasonable window of time to fix that vulnerability, and then release that information to the public. And hopefully by the time that information is released to the public, it's well known how to fix that problem. One option that doesn't work is discovering a vulnerability and doing nothing, right? That's really not the right thing to do because secrets aren't very easy to keep, right? So if anything known by more than one person is something known by the whole world almost, right? Because things spread around pretty quick. So you tell one person about this new vulnerability, and all of a sudden everybody's going to know about it. So you definitely want to let the company know as soon as possible, or the organization know as soon as possible who has the vulnerability so that they can take steps to fix it, but give them a reasonable deadline for when you're going to release it to the general public. So that's basically a 0 day attack, what a 0 day attack refers to. Cookies, we're going to swing back to the internet type stuff, web-based applications. Again, lots of application attacks can happen on the web. It's where a lot of the interesting ones are. Cookies, as you probably know, are little chunks of data that are stored in your browser cache. Cookies are basically what makes state possible on the web. So if you think about using a website, the internet, the World Wide Web, was never really designed to maintain state between a user and a server, between a client and a server. It was really only a document type system where you would be able to hyperlink to different documents. That was the early purpose behind HTTP and HTML and all that stuff. But fast forward to today, we have all these really cool web applications that can do all kinds of neat things, but the only way it can do all that stuff is if we have this concept of stateful connections between the client and the server, between the web browser and the web server. To make that possible, we use cookies. So cookies are pushed from the server down to the client side, and then those tracking cookies are constantly transmitted back to the server so we can maintain that state, that session between a client and a server. The idea of logging into a website would not be possible without cookies. I shouldn't say that 100%. I mean, you can do some session logging or some session tracking from a URL, but it's not foolproof. It's kind of a hack, but it does work. So if you turn off cookies and try to go to facebook.com, you'll see all kinds of junk in the URL that they're trying to use to track your session because they want it to work even if you have your cookies turned off. Generally, it's not a good idea to completely disable cookies because they're useful for lots of things. But cookies can also be used for bad things. They can be used to track you and so forth. I learned this lesson last year when I don't actively worry about cookies all the time. They're so ubiquitous. Everybody uses them. I went to, I was kind of amazed because my family, we were going to go to Disney, and I started searching for hotels for Disney. And I had never seen advertising for Disney anywhere on the web, ever. All of a sudden, One time I did a search for a Disney hotel, and I had Disney advertising for months all over every web page I went to. So I went to slashdot.com, there would be Disney advertising everywhere. And Disney has nothing to do with slashdot.com or with hacker, whatever, all those websites that I might go to. All of a sudden, I'm seeing all this advertising for Disney. So clearly these cookies were getting passed around to all these different websites to advertise the fact that I was searching for Disney. So just even something seemingly benign, they can track you with these cookies. So if you suspect that cookies are causing a problem, you can simply remove them. But it's important to know about cookies from a user perspective. Users should know that they exist and how they're used and that they can manage that. So another thing we talk about is locally shared objects. Very similar to cookies, but locally shared objects are more broad than cookies. It's a little more vague, right? So basically your book says they're pieces of information that are stored on a user's computer to save information from an application. So it's the same idea of somehow getting state in a stateless environment. And they do this by writing flat files. Cookies themselves are examples of locally shared objects, temporary files, database files, an MDB file or something like that. These are all examples of locally shared objects that would be stored on a device that could contain information that's private, and somebody could go in and get that information, or they could use that locally shared object to hijack your session, right? So if somebody got a hold of, let's say I had a banking application on my phone, and that bank application writes all of its variables to a locally shared object on my Android phone. And somebody gets that locally shared object from my Android phone and copies it to their phone and replaces their locally shared object, and they've got the same app, maybe they can go in and log into that bank as if they're me. So that's one way you could use a locally shared object to hijack. So whenever you suspect something's happened, that a locally shared object is sharing that information or storing that information, it's a good idea to delete it or remove it. Most people don't even know that these locally shared objects exist, right? So if somebody has an Android phone and sells it on eBay and they think that they wiped their phone, but really all these locally shared objects are still left behind, an attacker could theoretically take those and reinstall those apps and reestablish a connection as if they're the original user and use their Facebook page or something. So it's important for users to be aware of their existence and know that they should remove those if possible. The last thing we're going to talk about for application attacks is malicious add-ons. A lot of applications, especially web browsers, right? So web browsers are infamous for having these add-ons. Almost every major web browser has the ability to add add-ons that add additional functionality to that program. Some of those add-ons, while most of them are useful and do some good stuff, some of them are malware. And, as previously discussed, we already talked about things like Trojans. Malicious add-on is a perfect example of a Trojan. Somebody downloads some browser plugin to play games or a browser plugin to do automatic searches or block advertising or something like that, only to find out that it actually does some other nefarious stuff. Maybe it does tracking so they can give you their own advertising, or it redirects your searches to commercial websites that pay for advertising and things like that. So all kinds of things that we don't want. So users should only install add-ons from trusted sources. So for example, if you're using Chrome, only get add-ons from Google or something like that, or get it from the App Store in Google, because there's at least a reasonable amount of vetting for those types of add-ons. The other thing your book talks about is not using unsigned ActiveX controls. It's literally one sentence in the book. Back in the old days, 5-6 years ago, we probably would have a whole paragraph to talk about ActiveX controls and how insecure they are. But I think we're finding that ActiveX controls are slowly dying. They only work in Internet Explorer for the most part, although I think there's some add-ons that you can get for ActiveX to work in something like Chrome. But for the most part, they're going away, but it's definitely something we have to be aware of. Unsigned ActiveX controls could certainly be malware, and that kind of falls under the category of malicious add-ons. All right, so we talked about a lot of stuff. That's over an hour of me talking, so I'll end here. If you have any questions, please let me know, and thanks for watching.